In example 3, we're just going to practice some regular integration and using an antiderivative function, and we're going to find that area or the displacement on the antiderivative from the bounds. So for A, we're finding a definite integral, which is area. So we're going to anti-differentiate sine. So anti-differentiating sine, we get negative cos. We're going to anti-differentiate the e, so we're going to end up with just the same function. And then we're going to plug in our bounds from 0 to 1, and that will give us, we are going to evaluate that area by plugging in. So we end up with negative cosine of 1 plus 2e to the 1. And then we're going to plug in our 0 into this expression. So we're going to end up with negative cosine of 0. Cosine 0 is 1, plus 2 times e to the 0, which is also 1. So we can simplify that to negative cosine of 1 plus 2e plus 1 plus 2. Okay, so this, I can kind of combine my like terms. So I have 2e plus 3 minus cosine of 1. So there's the area under that antiderivative function. The area under the function sine x plus 2e to the x from 0 to 1. For this one here, I need an antiderivative for cotan cosecant. If I check my formula sheet, well, that's the derivative of cosecant is negative cosecant cotan. So I know the antiderivative for this should be negative cosecant. Cosecant x, and I'm going to evaluate that integral from pi over 4 to pi over 2. So plugging that in, I get negative cosecant of 1/2 minus negative, so I'm going to plus cosecant of pi over 4. Okay, so cosecant is a reciprocal of sine, so I'm going to start with sine of pi over 2. Okay, so I'm just going to move that over here. If I draw my circle in here at pi over 2 at the very top, the sine value is equal to 1. So that's going to be negative 1 plus cosecant of pi over 4. So pi over 4 is here. The ratio of sine is going to be 1 over root 2. So I'm going to flip it. It's going to be root 2 over 1. So my area under that curve from pi over 4 to pi over 2 is going to be root 2 minus 1. For this one here, we're going to take the antiderivative of 1 over x plus 1. If I try using power rule, I'm going to end up dividing by 0. This is not a power rule. This is our exception. This is a log function. So we're going to do log of the denominator 1 plus x, or x plus 1, plus the antiderivative of cosine is sine. And I'm going to plug in my bounds from 0 to pi over 2. Okay, evaluating these bounds, I'm going to plug in my bounds. So log pi over 2 plus 1 plus sine of pi over 2. Sine of pi over 2 we already worked out as 1. And then minus, when we plug in the other bounds, I'm going to plug in 0. So I'm going to end up with these brackets, log 0 plus sine 0, which is 0. Okay, so this ends up being log pi over 2 plus 1 Okay, that's a positive value, so I don't need those brackets. So I don't need the absolute value, plus 1. Okay, so there's my solution, my area under that curve from 0 to pi over 2.